It is very hard for archaeologists to explain how that was done using purely leverage and mechanical advantage.
What if the Egyptians left behind a picture of the machine they used to cut granite, and we simply misunderstood what we were looking at? Thousands of years ago, Egyptian craftsmen were cutting one of the hardest stones on Earth, granite. And the strange part isn't simply that they managed to cut it. Some ancient granite surfaces contain long, controlled grooves, remarkably straight cuts, and drilled holes, marks that suggest a method far more sophisticated than simply striking stone with copper tools. But there's an even more intriguing clue. Certain Egyptian reliefs and inscriptions appear to show craftsmen working with long tools, frames, ropes, and mechanical arrangements. When these images are compared with the marks still preserved on ancient granite blocks, a completely different picture begins to emerge. And what these clues reveal could change the way we understand ancient Egyptian stoneworking. Because these hieroglyphs may not simply show people working with stone, they may preserve clues to how the granite was actually cut and the machine that made it possible. Before we ask how these objects were made, we need to understand what they actually are. These enormous granite boxes are located inside the Serapeum at Saqqara, an underground complex associated with the ancient Egyptian worship of the Apis bull. The complex was expanded over centuries, particularly during the New Kingdom and later periods, and the massive granite sarcophagi found inside were intended to house the remains of the sacred Apis bulls. But these were not ordinary sarcophagi. Some of the granite containers weigh dozens of tons. Their lids are enormous blocks of stone, and the boxes themselves had to be transported, positioned, and finished inside a complex of underground chambers and passageways. And that creates the real engineering problem. It isn't simply that the Egyptians were able to move a massive piece of granite. It is that they were able to transform that massive block into a hollow container, create relatively precise internal surfaces, produce matching lids, and fit enormous stone components together with remarkable accuracy. And this is where the mystery begins. Because when researchers examine ancient Egyptian granite work, they don't find just one type of tool mark. They find evidence of chiseling, pounding, sawing, drilling, abrasion, and polishing. Some of these techniques are well understood. Ancient Egyptian craftsmen had access to copper tools, harder stone tools, abrasive materials such as quartz, rich sand, and enormous amounts of labor and time. So the real question isn't whether ancient Egyptians had technology capable of working granite. They clearly did. The more interesting question is this: how exactly did they combine these simple tools and abrasive techniques to produce objects on this scale, with surfaces and geometries that can still appear astonishingly precise thousands of years later? And that question becomes even more interesting when we look closely at the boxes themselves, because the evidence is not limited to their size. It is hidden in the corners, the walls, the lids, the drilling marks, and the surfaces left behind by the people who made them. And once you start looking at those details, the boxes stop looking like simple stone coffins. They start looking like evidence of a sophisticated manufacturing process. So let's look at the boxes themselves, the boxes. To understand why these boxes are so impossible, you need to understand granite itself. Granite is one of the hardest natural materials on Earth. It sits between 6 and 7 on the MO scale, the standard system scientists use to measure how hard a material is. Steel sits at around 4 to 4.5 on that same scale, which means granite is actually harder than steel. Even today, engineers can only cut through it using diamond-tipped machinery because diamond is the hardest material known. And even with diamond tools, cutting granite is slow, loud, and expensive. Now look closer at what is inside these boxes. The interior corners are sharp, not rough, not approximately square. They are cut into perfect right angles in solid granite. To cut a sharp corner like that, a tool needs to fit inside that tight space and still cut with full power. No tool from ancient Egypt has ever been found that can do this. Not one. Then there are the lids. Each lid weighs 27 tons. These were not simply placed on top of the boxes. They were fitted to them. The gap between each lid and its box is less than the width of a single human hair running across the entire edge. Picture two surfaces, each weighing more than 20 tons, sealed together in solid granite with almost no gap at all. That level of precision would challenge even a modern fabrication workshop today. The floors inside these boxes are just as strange. Several show no tool marks anywhere. Not faint marks, not worn-down marks, nothing. The surface is so smooth it reflects light, like a mirror. The only way to achieve that kind of finish today is with industrial polishing machines that run for hours. Nobody has ever explained how copper tools and sand could produce a finish like this. These are not crude storage boxes. They are precision-built objects cut to tolerances that would push the limits of modern technology. And according to the official story, they were built by a civilization using nothing but copper chisels and stone hammers. One detail makes this even darker. In 1851, when French archaeologist Auguste Marat first entered this tunnel, he found one box still sealed shut. Its lid was cemented down with mortar so fine it left no gaps at all. When his team finally broke the seal and opened it, the box was completely empty. It had not been robbed. It had not been disturbed. It had been sealed shut perfectly around nothing. Nobody has ever explained why. And there is something else Marat recorded. After the first week of digging, several of his own workers refused to go back into certain parts of that tunnel. He never explained why. He only noted that they would not return. The boxes are still down there today. The questions are still unanswered. And after more than 100 years, the official explanation has never come close to solving any of it. The official explanation. For more than 100 years, mainstream Egyptology has given the same answer to how the ancient Egyptians cut granite, copper chisels, stone hammers, abrasive sand. That is the official position. It is in the textbooks. It is on the museum placards. It is what every student learns. So, let us take it seriously. Let us actually test it against the evidence, because that is something the official position has never done itself. Start with copper. Copper is a soft metal. On the Mo hardness scale, copper sits at around 3. Granite sits between 6 and 7. In basic material science, a softer material cannot cut a harder one. The softer material simply wears away and destroys itself. If you press a copper chisel against granite and strike it, the granite does not chip. The copper does. This is not a debatable point. It is physics. And yet, this explanation has been accepted without a single full-scale test to prove it works. That is the most damaging fact about the official position. In over a century of mainstream Egyptology defending the copper chisel theory, nobody has ever attempted to cut a granite surface to the tolerances found inside the Serapeum boxes using copper tools and abrasive sand, and actually succeeded. No controlled experiment, no replication study, no demonstration. The theory has never been proven. It has only been repeated. Now look at the abrasive. The official story says sand was used as the cutting material fed between the tool and the stone to grind through the granite. But the actual abrasive found inside the ancient drill holes at Aswan is not sand. It is corundum. Corundum is a mineral with a hardness of 9 on the Mo scale. It is the same material used in modern industrial grinding discs. It is extremely effective at cutting through hard stone, and it does not occur naturally anywhere near Aswan or the Nile Valley in workable quantities. The nearest natural deposits are in the eastern desert and in parts of southern Africa, hundreds to over 1,000 miles away. Someone found it. Someone transported it across that distance. Someone processed it into a paste and used it deliberately at multiple quarry sites across Egypt. That is not primitive. That is an organized, large-scale industrial operation. The copper chisel theory cannot explain the sharp interior corners. It cannot explain the sub-millimeter lid seal. It cannot explain the mirror-grade floor finish. And it cannot explain why the abrasive found in the actual ancient drill holes is not sand at all, but a precision industrial mineral sourced from hundreds of miles away. The official explanation is not just insufficient. It has never been tested. It has never been demonstrated. And it is directly contradicted by every piece of physical evidence left behind in the stone. So, if it was not copper chisels and sand, what does the stone actually show? Because when you look at the cuts under magnification with calibrated scientific instruments, the evidence is specific, measurable, and deeply unsettling. The physical evidence. The cuts in these granite boxes are not just smooth. They carry a specific physical signature, and that signature tells you exactly what kind of process made them. This is not guesswork. This is engineering. Here is the most important finding. When any cutting tool touches granite, whether it is copper, iron, or even a modern diamond drill, the impact creates tiny cracks just below the surface inside the crystal structure of the stone. These cracks are unavoidable. They are simply what happens when force meets stone. Every tool leaves them, every single one without exception. The Serapeum boxes have none. 0 cracks below any cut surface. The crystal structure underneath every cut is completely undamaged. The granite did not fracture below the cutting line. It separated cleanly at that exact boundary, as if the stone simply let go at that one point and left everything beneath it untouched. There is only one known process that can cut granite without leaving any cracks underneath. It is called ultrasonic cutting. In this process, a tool vibrates at a frequency above 20,000 cycles per second, far faster than any hand tool could ever move. At that speed, the vibration breaks the bonds between the stone's crystals so quickly and precisely that the granite separates cleanly without cracking anything below the surface. The result is a clean, exact boundary, with no damage underneath. That is exactly what the Serapeum boxes show. Now look at the drill holes at Aswan, where ancient workers once cut blocks directly out of the quarry. In 1983, engineer Christopher Dunn measured the spiral groove left inside these holes. The groove cuts through the granite at a rate of about 1 millimeter per rotation. That number sounds small, but it is staggering. To cut through solid granite at that rate, you need a precise combination of rotational speed and downward pressure. When engineers calculate how much power that actually takes, the number is far beyond anything a human-powered tool could ever produce. A bow drill cannot do it. A weighted lever cannot do it. A counterweight system cannot do it. The groove in that stone points to a power source with no human-powered equivalent anywhere in the ancient world. Then there is the heat. Under high magnification, the cut surfaces of the Serapeum boxes show a very specific pattern. The heat is concentrated at one single point of contact. It does not spread into the surrounding stone. When two surfaces rub against each other through friction, heat spreads across the whole area of contact. But when ultrasonic vibration strikes a surface in rapid micro-impacts, the heat stays locked at that one exact spot and disappears before it has time to spread. Pinpoint heat, not spread heat. That is exactly what the Serapeum surfaces show. And this is not isolated to one site. the same 4 signatures, 0 cracking beneath the surface, the 1 millimeter advance rate, the same abrasive material at the cutting edge, and pinpoint heat at the boundary, all appear again at the Valley Temple of Khafre in Giza, at the Abu Raj Quarry in the north, and at the inner sanctuary column bases at Karnak in the south. These sites sit hundreds of kilometers apart. They belong to different dynasties and different centuries, yet they all carry the exact same fingerprint. The same process was used across an entire civilization consistently for a length of time nobody can explain. One final detail makes this even stranger. Ultrasonic cutting at this frequency is completely silent to human ears. Anyone operating equipment like this would have felt its effects directly on their body. Pressure building in their ears, a sense of disorientation, vibration moving through their soft tissue, all without hearing a single sound. They were cutting through solid granite in complete silence. 4 physical signatures, all pointing to the same process. But that process needs something to power it, and that is exactly where the ancient world runs out of answers. The word nobody can read. Now, we leave the stone for a moment because there is a document that describes exactly what was used to cut that granite. It is a text written in hieroglyphs, and the story of how this document was almost lost forever is just as dark as anything found inside that tunnel. The year is 1938. An Egyptian man named Salem Hassan is completing what will become his final survey season as an Egyptologist. Hassan was not an ordinary figure. He was Egypt's first native-born Egyptologist to hold a senior excavation position, a man who spent his entire life reading and translating the records of ancient Egypt. During this final season, he comes across a hieroglyphic panel. It is written in administrative script, the same plain, practical style of writing that Egyptian scribes used for quarry logs, ration records, and shipping documents. Not religious writing, not mythology. Administrative writing, the kind used to record real, practical, day-to-day operations. Hassan files a short note describing it as a tool-related administrative text of uncertain classification. Then he moves on to other work. He never returns to it. He died in 1961. His note sits inside the Cairo Museum archive for decades, completely untouched and unexamined. In 2017, an independent researcher going through related survey materials finds the panel and photographs it. The photograph is shared on a restricted engineering history forum. Within 72 hours, the entire thread is taken down, and the researcher's access to the archive is revoked. But by then, the photograph has already been copied and shared elsewhere. What that photograph reveals is a hieroglyphic text describing a cutting mechanism broken into 3 distinct parts. The first part describes the tool itself. It refers to a large rotating tube pressed against stone under controlled downward pressure. The hieroglyphic symbol used here is significant. It is the symbol Egyptians used for mechanisms that spin and rotate, not for ritual objects or decorative items, but for actual functioning machinery. The text also specifies that 2 operators were needed to run it, and includes a scale measurement that rules out the idea of this being any kind of handheld tool. The second part describes the abrasive material. It names a paste called chaffé mixed directly at the cutting site. This is the same corundum paste that was later found as physical residue in the drill holes at Aswan. In other words, the inscription and the physical evidence in the stone are describing the exact same material from 2 completely separate sources thousands of years apart. The third part is where the inscription becomes something nobody has been able to fully translate. It describes the power source using a phrase that roughly translates to the perfect turning of the heavenly directive. But buried inside that phrase is one specific word, the word naming the exact type of power being used. And that word does not appear anywhere else in the entire Egyptian written record. Not in religious texts, not in literary texts, not in any other administrative document ever discovered. One word in one inscription with no match anywhere else in 4,000 years of Egyptian writing. This matters more than it might first seem. Egyptian scribes were highly trained professionals, and their vocabulary stayed remarkably consistent across centuries. A word that appears only once in thousands of years of standardized writing is not simply rare. It is a break in the entire system. There are only two real explanations for it. Either the scribe invented a completely new word that nobody else ever used again, or the scribe borrowed a term from something far older, something that existed before Egyptian writing itself was ever formalized. Neither explanation is comfortable. 3 separate scholars have studied this untranslatable word. The first called it an unknown mechanism type and chose not to pursue it any further. The second identified it as a hapax, a term used in linguistics for a word that appears only once in an entire language's recorded history, making it impossible to confirm its meaning through comparison. The third, an Egyptologist at the Oriental Institute in Chicago, described it in a 2019 conference as a term from a vocabulary we simply do not have. Not partially understood, not loosely translated, we do not have it at all. The power source in this inscription has a name, but that name belongs to a vocabulary that has left behind no other trace in the whole of human history. Thanks for watching, and remember, history doesn't always tell us everything that happened. I'll see you in the next one.